Good morning students. Today we will learn 4th chapter Current, Electricity and Magnetism. Anything which has mass and occupies space is called matter. Every object is made up of matter. All matter is made up of particles called atoms. It means any object like pen, pencil, paper is made up of atoms. Atom is made up of same number of positively charged protons and negatively charged electrons. Means the pencil or even mobile in your hand also contains lots of charged particles. From this, we can say that plenty of electric charge is filled in objects around us. But have you ever felt this charge? No, we never experience this charge because an atom is electrically neutral. It means it do not carry any charge. As negatively charged electrons and positively charged protons are same in the number, they cancel each other and atom becomes electrically neutral. Last year you have studied that when glass rod is rubbed on silk cloth, glass quickly loses electrons and acquire positive charge, and silk gain electrons and acquire negative charge. In this way, electric charge is created when electrons are transferred to an object or electrons are removed from an object. But this charge remains still on the object. They can't move and hence they are called as static charges. Static means non-moving charges. Can this charge be made to flow like water flowing from the higher level to lower level? You have learned that in order to move stationary object, we have to apply force on it. In the same way, to move electric charge, we have to apply force on it. This force can be applied with the help of electric cell. We get current electricity when the electrons in an object are made to flow. Current electricity. Electric current is the movement of electrons through a conductor. You are aware that a large current flows when lightning takes place from a cloud to the ground, while sensation is felt by us due to a microscopically small current flowing to the brain. You are also aware of the current flowing through wires, electric bulbs, and equipments in the house. In the electric cells of radio or in a car battery, a current is produced by the flow of both negatively and positively charged particles. Electrostatic potential. All of you know that water or a liquid flows from a higher level to a lower level. Heat always flows from a body at higher temperature to a body at lower temperature. Similarly, there is a tendency of the positive charge to flow from a point of higher electric level to a point of lower electric level. This electric level deciding the direction of flow of electric charge is called electrostatic potential. Potential difference. Similar to the height of a waterfall, the temperature difference of hot and cold bodies, there is the difference between the potential of 2 points. This difference in electric potential between 2 points in an electric field is called as potential difference. Take connecting copper wires and connect the circuit as shown in the figure. No current is seen to flow in the bulb. We know this because the bulb does not light up when we close the circuit. It means there is no electricity running in the circuit. Now connect in the same circuit a 1.5 volt dry cell. Here dry cell is shown by drawing two parallel lines with positive sign at the one end and negative sign at the another end. As soon as we connect the cell and close the circuit, the bulb lights up. It means now electricity is flowing through the circuit. Why does this happen? Electric current start flowing through the circuit because electric potential develop in the circuit due to the addition of dry cell. Electrons in the wire start flowing from the negative terminal of the cell to the positive terminal of the cell. Conventional current flows in the opposite direction and is shown in the figure by the sign of an arrow. So, the black arrow shown in the figure shows the flow of current and not flow of electrons. The unit of potential difference in SI system is volt. We have seen that electric current is produced due to the flow of charged particles. Electrical charge flowing through a wire in 1 second can be called unit current. The SI unit of electric current is coulomb per second or ampere. 1 ampere is equal to 1 A, which is also equal to 1 coulomb per 1 second. Electric cell. An electric cell is a general device used to produce a uniform flow of charges in a circuit. Electric cell converts chemical energy into electric energy. Various types of cells are available in the market. These are used in a range of machines from wristwatches to submarines. You may be aware of the solar cells. Solar cell converts solar energy into electric energy. But what is the main function of electric cell? The main function of various electric cells is to maintain a constant potential difference between its two terminals, that is in between positive terminal and negative terminal. The electric cells work on the electric charges to maintain a constant potential difference. Let us learn about the electric cells that are currently in use. Dry cell. Dry cell is a type of electric cell commonly used for portable electric devices. So where dry cell is used? Mostly dry cells are used in our radio sets, wall clocks, remote controls, torch, etc. These are available in 3 to 4 sizes. Let us study dry cell in detail. Try this. Take a lead dry cell and remove its outer coating. Inside you will find a whitish metal layer. This is the zinc metal layer. Zinc is also a good electric conductor, so zinc is used here to carry electric charges. So in the figure, this blue color is the outer coating and the zinc metal is shown by the yellow color. Here zinc metal acts as a negative terminal of the cell. Now carefully break open this layer. There is another layer inside. Below the zinc layer, there is a brown layer which acts as a electrolyte. Electrolyte is non-metallic electric conductor in which current is carried by the movement of ions. The electrolyte contains negatively and positively charged ions. It is a wet pulp of zinc chloride and ammonium chloride. There is a graphite rod at the center of the cell. This is positive terminal of the cell. A paste of manganese dioxide is filled outside the rod. Manganese dioxide is used to protect graphite rod. Because of the chemical reactions of all these chemicals, electric charge is produced on the two terminals and an electric current flows in the circuit. Due to wet pulp used in the cell, the chemical reaction proceeds very slowly. Hence, a large current cannot be obtained from this. Compared to the electric cells using liquids, the shelf life of dry cell is longer. Dry cells are very convenient to use as this can be held in any direction with respect to the ground and can be used in mobile instruments such as remote controls, torch or radios, etc. Now let us study the second type of cell, that is lead acid cell. It is one of the oldest type of cell. This type of cell can be recharged after getting electrically discharged. The lead acid cell contains a lead electrode and a lead oxide electrode, and both are dipped in a dilute sulfuric acid. Oxide acts as a positive terminal while lead acts as a negative terminal. The potential difference between these two is nearly 2 volt. Because of the chemical reaction between the substances in the cell, that is lead oxide, lead and sulfuric acid, electric charge is produced on both the electrode and electric current flows through the circuit. This kind of electric cells have a capacity to deliver large current. Hence, lead acid cells are used in cars, trucks, motorcycles and UPS, that is uninterrupted power supplies. Nickel cadmium cell. The nickel cadmium cell is a type of rechargeable cell using nickel hydroxide and metallic cadmium as electrodes. These days, a variety of gadgets are available which are required to be carried to the different places. Such gadgets use nickel-cadmium cells. Lithium-ion cells. Lithium-ion cells are used in modern equipments like smartphones, laptops, etc. This cell can be recharged. More electrical energy can be stored in these cells as compared to that in nickel-cadmium cell. Electric circuit. When a cell holder, an electric bulb and plug key are connected by connecting wires and a dry cell is fitted in the holder, then the bulb lights up by closing the plug key. This means that a current flows through the circuit and bulb lights up. On the removal of the cell, the electric current flowing through the circuit stops as indicated by the bulb which ceases to glow. That is, it stops to glow. This happens because when we remove the cell out, there is no potential difference applied to the circuit and hence current stops flowing and the bulb does not light up. This type of connection of electrical components along which an electric current flows is called an electric circuit. Connecting cells. You must have seen more than one electric cells connected in an electric circuit. In the transistor radio, 2-3 dry cells are seen to be connected in series. The purpose of doing this is to obtain more potential difference than that of a single cell. Therefore, it is possible to obtain higher current. If the cells are connected as seen in the figure, the connection of cells is known as a battery of cells. But how to connect the cells in order to obtain more potential difference? It is very important to connect the cell correctly. In the series connection, connect the positive terminal of one cell to the negative terminal of the second cell and the positive terminal of the second cell to the negative terminal of the third cell. Suppose there are 3 cells in the series and if each cell has a potential difference of 2 volt, then the total potential difference of the 3 cells will be 6 volt. Magnetic effects of electric current. Try this activity. Take magnetic needle, a bar magnet and connecting wire. Mark the position of the magnetic needle. Take a bar magnet near to the magnetic needle. What do you observe? The magnetic needle changes its direction when a bar magnet is taken near the magnetic needle. Now take the inside tray of an used up matchbox and place a magnetic needle inside the tray. Complete the electric circuit by connecting in it the wire, electric cell, plug key and a bulb. Keep looking at the needle and close the plug key, means switch on the circuit. The bulb will light up and you will realize that the current has started flowing. Does the magnetic needle change its position? Yes, the magnetic needle changes its direction when a current starts flowing in the circuit. Now open the plug key. Does the magnetic needle come back to its original position? Yes, magnetic needle again come back to its original position when current stops flowing. This means that the magnetic field is created when an electric current flows in a wire. From this activity, we can say that when an electric current passes through a wire, a magnetic field is produced around that wire. Electromagnet. Try this activity. Take a meter-long flexible copper wire and wind it tightly on a long iron screw. Connect the two ends of the wire in a circuit. Also connect an electric cell and a plug key in the circuit. Keep 2 to 4 iron pins or small nails near the screw. Now start the current in the circuit by plugging the key. It will be noticed that the pins have stuck to the tip of the screw. Will the pins continue to stick when the plug key is open? No. When the plug key is open, it means current will not flow through the circuit and the pins will not stick to the nail. This experiment shows that when the electric current flows in the wire, magnetism is produced in the coil around the screw and because of that the screw also attains magnetism. As soon as the current is stopped, this magnetism vanishes. The system of coil and the screw is called an electromagnet. Electric bell. Many of you must have seen the simple electric doorbell. Open such a bell which is out of order. This is the inner structure of the bell. Let's see its basic components. This is the switch which we press to ring the bell. This is the copper wire wound around an iron piece. This coil acts as an electromagnet when electric current flows through the circuit. This is the battery and striker. Striker hits the gong and we hear the sound. But this electric circuit is not complete. When we push the button, the circuit gets completed and current flows from positive terminal to the negative terminal. When the current flows through the coil, it acts as an electromagnet. This electromagnet then attracts the iron strip towards it. In this process, the striker strikes the gong and the sound is produced. But notice what happens when the striker hits the gong. At the same time, contact screw loses the contact with the strip and the circuit breaks and the current flowing in the circuit stops. Electromagnet loses its magnetism and the iron strip moves back and comes in contact with the contact screw. The electric current is then immediately restored and again the striker hits the gong by the above process. This action repeats itself and the bell rings.